Hey, welcome back in. Hope everyone's doing well. We're in topic 2, moving forward. We are going into, I'm going to split it down the middle here. We're talking about relations and functions. We'll just put a line down the middle. Close enough. Maybe we'll redraw the line. Functions. All right, and to start off with, all I'm going to do, I'm just going to write the definition. All right, so let's get the definition. So we're going to say a relation between, how do we want to say this? I'll say relation between two sets. And we're going to say these sets are A and B. And B is a collection of ordered pairs containing one object from each. And this definition will make more sense as we go through examples. Containing, let's say, one, we'll call them object from each. And so I'll give you an idea here just briefly. Right, I just want to really use this for definitions, but just so you get the idea of what this is saying. Say we have two sets. Right, a set is just a collection, right, of a bunch of objects. Say this is, we'll use letters here, A, B, and C, and we'll say set B is going to be equal to, we'll just do 1, 2, 3, and 4. Right, so let's read this. This is a relation between two sets, A and B, is a collection of ordered pairs. Right, so a relation, we're just going to say, well, R is our relation, is a collection, so it's a set of ordered pairs containing one object from each. Right, so let's take one object from A, and we'll group it with one object over here with B. Let's just say 2. Right, so this is an ordered pair. And A can go with many things here, and we'll discuss more about a relation and what is allowed in a relation, but let's say A can also go with, let's say 3, right? A is related to 2, A is related to 3. That's the way we want to think about that. We can do a couple more, right? Let's say B is related to 3. And let's write one more. We will do C is related to 4. Right, so we'll leave it just like that. Now there's a key thing here that makes this only a relation. We'll see what I mean by that in a second, but we need to define function so we can compare and contrast. So again, a relation between two sets A and B is a collection of ordered pairs. So a collection of ordered pairs, collection R of ordered pairs containing one object from each. Right, so there's one object from A, one object from B. Right, one object from A, one object from B, all the way through. Right, that's the only qualifications you need to have in order to be a relation. Right, the only qualifications you need to have is that you're a collection of ordered pairs and one of your objects is from A, one of your objects is from B. Right, that's the only qualifications. Now a function, you want to think of a function as a more strict version of a relation. So a function is a relation, but it has more strict qualifications. So let's go ahead and write the definition here. We're going to say functions are a relation, right? So they are relations from set A, the same thing that we did here, from set A to set B. So same idea, right? This is just the definition of a relation again, right? From set A to set B. Let's write B. is a function, right? So is a function if we have one more qualification. If every, I'm going to call them objects, every object in A has one and only one let's say image, and I'll discuss all these words, image in set B, right? You could think of only one related to object in set B. So we'll discuss this definition. Right, so again, a function is a relation, but it has an extra qualification, right? If we read this, a relation from set A to set B, so it is a relation, and it is a function if every object in A has one and only one image in set B. Right, now you'll notice I use the word over and over again, objects. If you see in your book, they might call them elements, right? That's fine, either word is okay. You could think of them just as things, right? So let's do the same thing. I'm going to use the same sets over here, A and B, but let's make sure it's a function now. Let's see why this over here is a relation, but not a function, right? So let's write out set A one more time, just so we get, even though it's going to be the same, it'll bother me if it's not symmetric. 1, 2, 3, and 4. Okay, now I'm going to say this is going to be a function, right? So I'll just call this f, and maybe this is bad notation, but it's fine for right now. And it's a set, still of ordered pairs, right? Because it's a relation. But what it's saying now is if I choose one object from A, and let's just pick little a here, it can only be related to one object or image in B, right? So let's say it's related to 1. That is the only image that A can be related to. I can't write A2. Notice over here I have A2 and A3. For a function, A can only be related to one thing. That's it. So once we've used A, we're done. Right? Let's write another one. If I go ahead and choose B, I can relate it to 1 again. That's fine. But it can only be related to one thing. Right? I can't put B is related to 1. Right, B is related to 1, and B is related to 2. I can't do that if I'm trying to define a function. And maybe we pick C, and we say, okay, this has, right, it's related to 3. Right, this is okay. This is a function. For every one object in A, it's related to one and only one image in set B, or one object in set B. Right, over here, for a relation, right, A is related to 2, and A is related to 3, so it's no good. This is a relation, but it's not a function because it's related to 2 different objects. Over here, right, again, this is the key point. One object in A, it can be related to only one object in B. That's the way it works, right? I know it seems a little abstract because all we're talking about is definitions and these sets that maybe we will never use, but we'll go through some examples and we'll make this a little bit more clear as to what the difference between these two are. All right, I will see you shortly. All right, now that we have the definition set, let's see if we can get some sort of visual representation that might help our understanding. So again, I'm going to split the board. We'll do relations over here. And over here, we'll put functions. Okay, and to get a visual, what we're going to do, remember, a relation is an ordered pair from set A to set B. So you know what we're going to do? We're going to draw 2 blobs here, denoting set A and set B. And we're going to come up with some more vocab terms here. We'll call this set A and this set B. Right, now set A and set B also have some other names they go by. Set A here is going to be called the domain, right? This is the first object in our ordered pair. right? You could think of the domain as all the possible things, right, that we can plug in, essentially, right? Or we can start with, let's say, right? All of our possible inputs. And B is going to be our range, right? All of our possible outputs. And I'll even write that. You could even, again, we'll write this out as inputs. And over here, we'll write this out as outputs. Okay, let's write these out. Right, I had A, B, C, and I had 1, 2, 3, and 4. Right, so a relation, again, is a very loose association, right? A can be related to many things. B can be related to many things. C can be related to many things, right? It's a very loose association. So we just have our set of ordered pairs here. We'll denote it with an R. And we'll say R is equal to the set, and it's going to be the set of ordered pairs. And let's just make up these relations. Let's say, I'll use a different color. Let's say A goes with 1. Right, so A goes with 1, and because it's a relation and we don't have many qualifications to be a relation, we can say, well, let's have A also go with 2. Right, so A can go with both 1 and 2. Right, so again, A is coming from our domain, where 1 and 2 are coming from our range, which is B. Let's move over, let's say B. What if B wants to go with both 3 and 4? So we'll say B will go with 3, and B can go with 4. And what about C? Well, let's just have C go with one thing. Let's say C goes all the way with 1. Right, so the key thing here with relations is that one of the objects in the domain, right, A, B, or C, can go with many objects in the range, right? So A can go with 1, and A can also go with 2, right? Sometimes I might use the word map. So A maps to 1, A also maps to 2. Another word might be related. A is related to 1, A is related to 2. So A can be related or mapped to multiple things, right? And same with everything that's in our domain, right? It can be mapped to multiple things. Whereas for a function, all right, we'll do our same blobs over here. We'll say A, B, and C. And same thing, another blob. We'll say 1, let's put the dot over here. 2, 3, and 4. Right, now for a function, think of it as a relation, but it has one extra qualification. Right, the extra qualification is saying, let me write this really quick. The extra qualification is saying that if I take one of my objects here in my domain, right, A, it can only be mapped or it can only be related to one thing in B, which is my range. Only one thing. Right, so we'll say I'll call this F for function is equal to the set. So if I go ahead and I choose A to be related to, pick whatever you want. Let's go with 3. A can only be related to 3, nothing else. A can't go with 1, it can't go with 2, it can't go with 4. It can only go with 3, right? Think of A as already done. Once it's related somewhere, it's out. Can't be chosen again. Let's go with B. We'll say it's related to 1. Again, once B is related to something, can't go with any other thing in our range. And we'll say C will do straight across. C goes with 4. Right, so again, notice the difference here. Over here in a relation, A can be related to many things, right? Things in our objects in our domain can be related to many objects in our range. For a function, objects in our domain can only be related to one thing in our range. Right, so that is the key difference here, and that's really all we need to grasp. Right, so we've looked at this in blob form, we've looked at this in what's called kind of like set form or roster form. We'll do a few different visual representations. I will see you shortly. Okay, So same thing. How do we identify the difference between relations and functions, right? We have two forms that I want to look at. All right, so again, I'm going to do split down the middle. We'll talk about relations. So again, relation is a very loose term. It's just a set of ordered pairs where one of the values, the first value is coming from the domain or set A. The second value is coming from set B, which is the range, right? So let's say I have a table, right? So this is like a table view. Do my best drawing of a square there. And on one side, we have all the inputs. Maybe I'll have to add a little bit of space. And on the other side, we can think of inputs as the domain, right? And on the other side, we have outputs, right? Output, you could think of the range. Right, so let's say we'll use the same sets I've been using, right? I plug in A, right? I get 1. I plug in A, I get 2. So immediately, as soon as I see this, right, I go A goes to two different things. That's only possible if this is a relation, right? That's only possible if this is a relation. I'm going to do another example too where we just use all numbers. We'll get rid of the letters. But for right now, right, so as soon as we see this, we know this has to be a relation. It's not a function, right? Same thing. Let's do B only goes to 3 now. And I'll do some more down here. Let's say C goes to 1, C goes to 2, and let's say C goes to 3, right? C can go with all of them, right? Because it's a relation, right? All of your values that are in your domain, which is A, B, and C for us, can go with as many values as we want in our range, right? There's no limit. I'm not going to write this out as far as the rostered form and the set form. But again, the key thing here that's a dead giveaway is that if any of the objects, right, any of the objects in our domain, our inputs, go with multiple, right, outputs, so A goes with 2 different things, C goes with 3 different things, right, I know that's going to be a relation. Over here, right, for a function, let's draw our chart. In this case, I don't need to draw as large of a chart, and we'll see why. Again, same thing, we have inputs, right? Again, inputs are domain, and let's say outputs being the range. Okay. So let's say for my inputs, I know for a function, if I plug in something from the domain, right, A, B, or C, I can only plug it in one time to get one value coming out, right? It's one and only one output for every input. So let's say this goes with 2, let's say this goes with 1, and we'll say this goes with 2. Right, so again, as long as I'm taking one object from my, right, set A or my domain, my inputs, and I'm getting one object from my outputs or my range, I'm okay. It doesn't matter that they're going to the same value too. That's totally fine, right? As long as A is not going to multiple things as it is over here, or C is not going to multiple things as it is over here, right? We only have one output for every input. That is all we care about, right? So a little bit of a shorter side of the video. I don't really have as much space as I thought I would. We will see what this looks like graphically, right, in like an XY coordinate plane when we come back. All right, last visual of both, right? Relations and functions, and I'll do a couple examples. All right, so I'm just gonna let's just talk about relations for right now. So how can we tell, based off a graph, if something is a relation? All right, so if I draw a graph, let's say we're gonna draw a random graph. Right, this is my x-axis, this is my y-axis, and you want to think of all your x's in this case as your domain. What can I plug in? Right, so in terms of our definition, this is like set A. Any value that I pick along my x-axis will be like my set A. And my y-axis, right, is my range. Think of it as anything that I can pick from set B. All right, so I'll draw some random, let's say it goes and I'll draw it like this. This is fine. I'll do a few other ones too. Maybe I'll just do a quick screen of just relations. Right, so again, domains, right? For every domain, I can plug in whatever I want, right? So this would be an example of a relation. Why? I mean, what is the real thing? What is the real difference between this and a function? Well, imagine, right, this x-axis is all the values of my domain that I can plug in. So I can look and go, okay, in this case, right, this x value, which is in my domain, maps to two different things. It maps to up here, right, and it maps to down here, right? So when I plug in this x value, I get two different values. Let's say, for instance, this is, let's just call this a, right? And let's say this is 1 and this is -1, right? So you could see here, right, I plugged in a, and a goes with 1, and a also goes with -1, right? So a is mapping or is related to two different values here, right? The test that we would normally use to see if something is a function, which we'll talk about in a second, is what's called as the vertical line test. And all this says is that if I can draw a vertical line anywhere on my graph and hit 2 points, so in this case, right, if I draw a vertical line and I hit 2 points on my graph, right, then I know it's not a function, right? So I'll just say if more than 1 point hit, then relation, right? This is just a relation, right? So if it hits more than 1 point, which in this case, right, this function hits 2 points, right? It can hit more than 2, but 2 points is all we need. Then we know it's not a function. It's just considered a relation, right? Now, on the other hand, maybe I do have enough space for a function, right? You could think it's just going to be the opposite. So again, we have our xy plane here. Again, think of your x values as your domain, whatever you can plug in along this x-axis. And think of your y values as your range, right? Whatever is going to be that second value in your ordered pair. And let's do a common function that we might all know. Let's just do an easy one. Let's say f of x, right, for a function, is equal to x squared, right? This is just a parabola facing upward. Close enough, right? So the idea here is for a vertical line test, if only, let's say, if only 1 point is hit, only 1 point is hit, then it's a function. Right, then it's a function, right? So you could draw a vertical line wherever you want, right? I draw one randomly, boom, I'm only gonna hit 1 point. I draw another random one, I'm only gonna hit 1 point. Right, so no matter where you draw your vertical line, you will only hit 1 point. And if that is the case, then we know we have a function, right? So we've seen it graphically as far as, right, an xy plane. We've seen it in table form. We've seen it in blob form, right? And we've also seen it in roster form where it's in that set form. So those are the 4 different forms you'll see. Again, functions, 1 input, right, from the domain means you only get 1 output from the range. Relation, 1 input from the domain can go to many different outputs, right? So if I plug in a, right, it can go to 1, it can go to 2, it can go to 3. That's fine in a relation, right? Over here in a function, if I plug in something from my domain, let's just call it A, it can only go to one value. Let's say it doesn't matter what the value is, I'll just put 1 here because it's the number I thought of first, but it can only go to one value, right? I can't have like another A going to -1. This is no good. This would not be a function. A only gets to be plugged in once to get one output. Okay, so I think that's all I got for relations and functions. Again, if you watch this before class, you'll be very much prepared. We'll go into more examples. That's all I got for you today. I will see you guys in class. Thanks, everyone.